Hey, welcome back to part 2 in this sequence about how imports work under the hood in Python. Okay, so in the last video, we had manually modified this Python path variable before executing a program with the Python interpreter, and we saw that top-level children of any folders in this colon-separated Python path list can be used as top-level modules in import statements here. And specifically, if it is a folder, you're going to need an init.py file to be present in that folder. And now, the init.py file doesn't have to have anything inside of it, but it does have to be there, even if it's empty. Okay, so in this case, we modified the Python path environment variable, but there's actually a way to modify the Python path without needing to add this special qualification to the Python command, like this. In this video, we'll take this command here, and we'll get it to work by itself. And you can see right now it fails due to a module not found error. No module named packaging my other file. Okay, let's make this work. All right, so we're back in my nested file, and the first thing I'm going to do is import this sys package. In the sys library, there is a variable called path. So I'll print that out so you can see what it is. Sys.path. Okay, cool. And I'll comment this out because I know it's going to crash after I run it. Cool, so now I'm going to run this file. Look at this. This is an array of directories. And you probably would not be surprised to hear that this array of directories is the Python path array. So whenever we do import statements in Python, apparently Python is searching these directories for top-level imports. And as you can see, one of those imports is this site packages folder. And we saw way back in a previous unit that it's the site packages directory where packages land whenever we run the pip install command. So if I were to type pip install pylint, then a folder called pylint would land in this site packages folder. And because that folder is a top-level child of this directory in Python path, we could do statements in our code like import pylint. Of course, we never do that with pylint because pylint is primarily used as a CLI tool, but it's a library too. And it's written in Python, so there are parts of the pylint codebase that you can interact with code. But okay, the point of this video was going to be how we could do a hack to make it so that this from packaging.myOtherFile import statement becomes valid. Well, if we hover over the path variable, we can see that VS Code's type inference for this variable is that it is a list of strings, which we know how to deal with. If we could just insert a string into this list of strings, then we'd have modified the path in the middle of a Python runtime. Let's try it. So I'll copy the beginning of this path right here up to repos. And I'll say sys.path.insert, and I'll insert at the 0th index this string right here, home/eric/repos. And remember, a child of the repos folder is this packaging directory here. And again, because packaging is going to be a direct child of this directory path, we'll be able to use it as a top-level module in an import statement, just like this. Cool. Well, if what I've been telling you is true, then now we should just be able to run python my folder mynestedfile.py. And it totally succeeds. Here's hi down here. So awesome. You know, we haven't talked about how to make our own packages yet. And I told you that if you learn to create packages, then you can start to write code bases that take advantage of using more than one file. But hey, even if you didn't learn how to write packages, you could just add these sys.path.insert statements to all of your programs, and you could do imports. I would recommend not doing that though, and I'll give you a few reasons why. One reason is that we can see that auto-completion is totally broken right here. If we were to turn this into a proper package, we could get this line to turn green and we could get auto-completion on it. And we just had 8 videos on MyPy and type hinting and auto-completion, so hopefully you're sold on why that's a good thing. But you know, I bet if you're a master of VS Code settings, you could find a way to have VS Code give you some auto-completion on this, even if it weren't a proper package. Another issue here is that I've hard-coded this absolute path, which we could actually derive this fairly easily. But as we start to rely on specific paths, even if they're not derived, our code becomes less portable because we start to make assumptions about the folder structure of the machine that this code is running on. You might be able to work around that too by dynamically creating files and folders from code. But I mean, how hard do you really want to work around just learning how to make packages? Which, by the way, used to be a huge pain, but in recent times, it's become very accessible, especially given the knowledge that you have after doing however many of the previous videos in this course that you did. Before we finish, I want to add one last comment that didn't seem to fit anywhere previous in this lecture, and that is that if you notice, again, we do have the site packages folder right here, and this is the site packages folder that belongs to my Python 3.11 install. But if we were to create a virtual environment and then activate that virtual environment, the process of activating the virtual environment basically just appends the location of the virtual environment site packages folder right here to this list. This is really quick to show, so I'll just do it right now. I'll run python-m venv and then /venv to create a virtual environment named venv. And sure, I'll enable it in VS Code. And now I'll run source VBA and expand that for the activate script in the VN folder. Okay, and now the virtual environment is activated. And now if I run the script again and print out the path variable, we can see that the site packages directory in PythonPath has been replaced with the one inside of venv. So that's how virtual environments achieve isolation. They remove Python's ability to use the Python path to look at packages that are installed in the system install of Python. So packages that are in the previous site packages folders that we saw up here. And instead they replace that and have the Python interpreter look at this site packages folder instead. Okay, so that is how the import system in Python works. And now you know what PythonPath is if you didn't know before. If you want to follow along, then you could reproduce this exercise yourself by creating a folder with a Python file and then trying to import something from a file higher up in the file tree. And then you could try doing some PythonPath hacking from the terminal to make your import statements work, as well as directly from Python code, using sys.path to modify PythonPath. Just know that that is a terrible, terrible practice, and you should never ever do it. Unless, obviously, you have a valid reason to do it, then do it. In the next video, we're going to talk about how to solve this the proper way, which is by creating a Python package. So I will see you there.